Hello. Today's topic is speed time graph and area under speed time graph. This is Raza Kayani. You are watching revision series of IGCSE GCSE O-Level Physics. At the end of the lesson, you will be able to calculate the acceleration of an object from the speed time graph. You will be able to draw the tangent on a curve to calculate acceleration of non-uniform acceleration. Calculate the distance traveled by an object from the area under the speed time graph. Different objects, they move with different speed and with different acceleration. Warning, don't mix distance time graph with the speed time graphs. For an object accelerating from rest position, it might have a different graph. You see that. So for the same object, the distance time graph is different, and velocity time graph has a different shape, and acceleration time graph has a different shape. So there are different techniques, different ways to take the gradient to differentiate between distance, speed, or velocity, and acceleration time graph. The gradient of speed time graph gives the acceleration. So in distance time graph, the gradient of a distance time graph gives the speed. But in this case, the gradient of the speed time graph is going to give the acceleration. Acceleration can be calculated by using these relationships. For example, gradient is change in y value divided by change in x value. So here, velocity is along y-axis, and acceleration is along x-axis. So to find the acceleration, we can use change in y value divided by change in x value. That can be written as delta y or delta x. But in case when the graph is passing through the origin, we can also write a gradient of the graph is y divided by x. So the vertical distance we can take as a y, and the horizontal distance can be taken as x. But if we want to calculate acceleration in between these 2 points, P1 and P2, if P1 is having coordinates x1 and y1, and P2 having the coordinates of x2 and y2, then acceleration of between these 2 points can be calculated by the gradient of the graph by using this relationship. As we are talking about the speed time graph, so that side could be taken as a delta v, that means change in velocity. And this horizontal distance can be written as delta t. So in that case, this is y2 and that one is y1. And that time down could be x2 and this time x1. But we have another way to calculate acceleration by using rise over run. The vertical distance we take as rise, the vertical one, and run we take as a horizontal distance, the horizontal axis basically take as a run. Pause the slide for a few minutes and try to solve the next question by yourself and compare with my answer. The gradient represents the movement of a body. Calculate the acceleration. Here is speed time graph. We have a speed along y-axis and we have a time along x-axis in seconds. To calculate the acceleration, we have a different ways, as I told you. A equals rise over run. So you can use the value 10 divided by 5 to calculate acceleration. Or if you want to use coordinates, you can use y2 minus y1 over x2 minus x1. So the value of the y2 in this case is 10, and the value for y1 is 0 because the graph is passing through origin. So here is a y1 and that value is x1. This is x2 and that will be y2. So in that case, 10 minus 0 over x2 is 5. 5 minus 0. So we are going to see the unit now here, basically, that case. So if you see the units over here, that's the meters per second, and down is a second. The acceleration 10 divided by 5 is 2 meters per second per second. That's going to be 2 meters per second squared. This is how we write the unit for acceleration. Speed time graphs or velocity time graph of an object can give us the constant acceleration, zero acceleration, or deceleration. It depends upon the gradient of the graph. Consider a car is standing at a traffic signal. Here's a car standing at a traffic signal. As the light of the traffic signal turns green, the car is accelerating constantly from A to B. From B to C, it's moving with constant velocity. From C to D, driver applies the brakes and car decelerates constantly and stops at signal 2. So see what's happening. From A to B, it's moving with constant speed. From B to C, it's moving with constant speed. So when the driver reaches here at B and sees the light is turning yellow, so he's going to apply the brake and going to stop at D again. So that region shows the object is accelerating constantly. That means moving with constant speed. And that region shows the object is decelerating. So the reason for the constant speed also, like the driver has a fear of traffic violation. Sees there's a camera, so he's going to go with the constant speed. So constant speed mean the acceleration is 0 in that case. Now, speed time graph of the previous moving car from point A to B, B to C, and C to D can be drawn as under. So here it's a constant acceleration. It's not the changing acceleration because the gradient of the graph is constant. Here the car is moving with constant speed, so it has a 0 acceleration. And here the car is going to decelerate constantly and going to stop at D, so it has a constant deceleration. So that's the positive acceleration. That region is a positive acceleration, and that region is a negative acceleration graph. So we can find these acceleration from the gradient of the graph. Again, we can use the formula to find the acceleration y2 minus y1 over x2 minus x1. And we can get the value for the acceleration for different section of the graph. Stop the video for a few minutes and try to solve the next 3 questions by yourself and compare your answers with mine. The speed time graph shows the motion of a car. Which row describes the motion? So we are going to see what's happening. In the speed time graph, this is a constant gradient. That means it's the constant acceleration. And Q2R, the object is moving with constant speed. So we are going to see the option here. A, accelerating, moving at constant speed. That is most convincing answer here. B, accelerating, not moving. That's not possible because it's moving with constant speed. That's wrong. C, moving at a constant speed. No, it's moving with constant acceleration. That's also decelerating. No, moving with zero acceleration. That's also wrong. D, moving at a constant speed. That's wrong. It's moving with constant acceleration, not moving. It is moving with constant speed. So the option is only A, where object is accelerating from P to Q, and between Q and R, it's moving with constant speed. Now we are going to see another question. A girl goes from a ride on her bicycle. The diagram shows how her speed changes with time for a part of her journey. In which labeled section is she moving with constant speed? So we are going to see the constant speed basically. So we have four options: A, B, C, and D. So we are going to see the four section basically. That means the object is moving with the constant speed. That is the deceleration, constant deceleration of the object. C means the object is at rest, and D mean positive acceleration. The object is moving with constant acceleration. So the question was, in which labeled section is she moving with constant speed? So the answer is A, because that region is the only constant speed. If you look again, that means deceleration that means at rest, and this is the acceleration constant. The object is accelerating basically. We are going to try this question now. The graph represents the movement of a body. Calculate the acceleration from A to B, from B to C, and from C to D. So as we said earlier, acceleration of the graph can be calculated by using this relationship. So let's see the acceleration of the first section. So here's my y1 and that's my y2. Here's y2 and that's y1. So in that case, my y2 is 5, my y1 is 0, my x2 is 10 here, and my x1 is 0. So 5 divided by 10 is 0.5 meters per second over second. Why? The speed over here, that part of the graph actually, this part of the graph is a meters per second, and that's the second. So meters per second is going to be 0.5 meters per second squared. Now we can see the acceleration between, that was acceleration between A, B. Now we can find the acceleration from B to C. So again, if I use the formula over here, y2 minus y1, so here is my point y2, and that's y1. So both they have a same value, both they have a constant value in this case. So my y2 is also 5 and my y1 is also 5. and my x2 is 20, and here my x2 is 20 and my x1 is 10. So that's 0 over 10. 0 divided by any number equals to 0 meters per second squared. Now we are going to see acceleration from section C to D. So here we are going to use y2 minus y1 over x2 minus x1. So y2, this is the final point the object is going to stop at. So the y2 here, y2 is 0, if you see here. So 0, and y1, the object started from here, that is 5. And x2 is 35, and x1 is 20. So in this case, minus 5 over 15, that's going to be minus 1 over 3 meters per second squared. So negative sign shows that the object is decelerating. The previous graph, that was a uniform acceleration. Now we are going to see non-uniform acceleration at a changing rate. At the previous graph has a constant rate, that's the changing rate. To calculate the acceleration at any point on a speed-time graph, we draw the tangent at that point. For example, if you want to find the acceleration at that point, so what we are going to do, we are going to draw a tangent at that point. For example, at A, here is a tangent, here's a tangent, and that's the gradient of the graph. And at this point B, here's a tangent, and the whole thing is a gradient of the graph. So how can we calculate acceleration at any point of non-uniform acceleration? So we use the same technique over here. So we choose the point, okay, P1 and P2, for example, and the P1 is x2, P1 is x1, y1, and P2 is x2, y2. So to find the acceleration at point A, I can use this relationship, y2 minus y1 over x2 minus x1. So that's the way to find the acceleration. So if the gradient is steeper, so that has a large acceleration. So the gradient A is larger than gradient B. So that means at A, the acceleration is larger, and at B, the acceleration is smaller. Another reason to see the acceleration, we can see the angle. If the angle is bigger, that means it has a high acceleration for the speed time graph. And if this angle is smaller, that means it has a small acceleration. So we have two ways to see the steepness of the gradient, or we can measure the angle, or we can observe the angle and can decide about the value of the acceleration, whether it is a large acceleration or small acceleration. Now we are going to practice for non-uniform acceleration 2 more questions. The speed time graph shown is for a bus traveling between stops. Where on the graph is the acceleration of the bus is greatest? So we are going to see where the acceleration is greatest. We know that we take speed along y-axis and time we take along x-axis. We can take any unit of it could be meters per second or kilometers per hour for long distance. Time could be hour or minutes. So we are going to draw the gradient at different point to see the acceleration. So at A, that's the gradient. At point B, we can draw the gradient this way, the graph. And for C, that's the gradient of the graph. And for D is almost straight, here. So now at A, the gradient is small. So it means it has a low acceleration at A. Here the gradient is steeper, so it has a large acceleration. Here the gradient is 0, the slope is 0, that's why the value of the acceleration is also 0. And here it's a straight line, so slope is 0, that means acceleration is 0. The question is, where on the graph is the acceleration of the bus is greatest? So the answer is B, because the gradient is larger at B. Now we can try another question. An object is traveling in a straight line. At which labeled point is the object accelerating at a changing rate? So we are going to see the changing rate here. See what's happening at A. At A, that's accelerating constantly. At B, that is non-uniform acceleration. C is moving with constant speed. So it has a zero acceleration. And D, that is decelerating constantly. So the question is, at which labeled point is the object accelerating at changing rate? So here's a curve where the rate is changing. So the answer is B. Now we are going to try another question. The curved line on the graph shows the motion of a car. What is the acceleration of the car at the time of 4 seconds? So whenever they say at any point 4 seconds means we have to draw the tangent and then we have to draw the gradient. And in between, when it's non-uniform acceleration, we have to draw a right angle triangle. In most of the question, there is a 1 mark for the right angle triangle to draw. Now we are going to decide the coordinates of that right angle triangle. If here, the first point we are going to decide to take x1 and y1, and the second point is x2 and y2. So we can find the acceleration at 4 seconds by using the relationship A equals y2 minus y1 over x2 minus x1. So y2 in this case is 12 here, and y1, that is between 2 and 4, that is 3. And now we are going to decide about x2. x2 is 5. And we are going to decide x1, and x1 is minus 2. So that's going to be 9 over 3 meters per second speed, and over second, so that's going to be 3 meters per second per second. It's going to be 3 meters per second square. So the answer in this case is D. Now the last section of the lesson, we are going to talk about area under speed time graph. The area under a speed time graph, if this is the speed along y-axis and time along x-axis, so the area under speed time graph gives the distance traveled. So here, this graph has two sections, area A1 and A2. So we can calculate area, we can calculate the distance by dividing this shape into two sections, A1 and A2. That's the one option. And The other option is to find the formula of trapezium. So if we are going to decide this area A1 and that's the A2, so A1 is a right angle triangle, so we are going to use area 1 equals half times the base times the height. So that's the base and that's the height we can take. And the second one, it looks like rectangle, so we can length time width or length time height. Okay, so that's the second formula we can use. Or we can use directly one formula because this shape looks like a trapezium. So in trapezium, we have the one parallel side and we have the second parallel side up. So if we say this side A and the other is B, so we can use formula half times height times sum of parallel sides. So half times height, that's the height. Actually, we take vertical height in this case, and sum of the parallel side A plus B. Now, we are going to see this worked example. If we are going to calculate the distance traveled by the object, and we have this type of the graph, we can find the total distance by calculating the area of this shape up of right angle triangle and the area of A2 of the rectangle. So in this case, that's going to be half times the base. Base, the graph is 10 times the height. So that height is 70 minus 30, that's going to be 40. So 10 divided by 2 is 5. 5 times 40, that's going to be 200 meters because it's a distance. Now, what will happen to this area A2? So area A2 is a length time width. So length is 10 and the width of the graph is 30. So that's going to be 300 meters. So we can add up both shapes. Okay, the first shape is basically 200 meters and the second one is 300 meters. So the total is 500 meters. Now again, stop the video for a few minutes and try to solve the next few questions by yourself and compare with my answers. What does the area under a speed-time graph represent? Acceleration, average speed, deceleration, or distance traveled? As we have discussed earlier, area under speed-time graph gives the distance traveled. So the answer is D. We are going to try another question. The graph represents the movement of a body. How far has the body moved after 5 seconds? How far mean distance? Distance equals area under the graph, and area under the graph that look like a right angle triangle. So it's a half times base times height. So half times base is 5 seconds, and the height is 10 meters per second. So second is going to be cancelled with the second. It's that 5 times 5 is going to be 25. Only meter is left here in this case. So because it's a distance, so unit should be meter. So the answer in this case is C. We are going to try another question. The graph represents the motion of a car. What is the distance traveled by the car while it's moving at a constant speed? So we are going to see the different section of the graph. That means the object is accelerating constantly. That is the object is decelerating constantly. That section shows the object has zero acceleration because the gradient is zero, so acceleration is zero, and that shows the object is again decelerating constantly. The question is, what is the distance traveled by the car while it's moving at a constant speed? So this section shows only the constant speed. So we are going to find the area of this section. So again, distance according to the shape, it's a length multiplied by width. So the length is 25 minus 15. That's going to be 10. Here is a 25 and minus 15 is 10. And that's the vertical width or height is 10. So that's 10, okay. So 10 times 10 is 100 meters. So the answer in this case is A. We are going to try another question. The graph shows how the speed of a van changes with time for a part of its journey. In which labeled section is the van decelerating? So we have a four section here, A, B, C, and D. That means object is moving with zero acceleration with a constant speed. And that means the object is decelerating. That means the object is at rest. And that section shows the object is moving with positive acceleration, positive constant acceleration. The question is, in which labeled section is the van decelerating? So the answer is B over here, because here the object is decelerating constantly. Now we are going to try the last question. The graph represents the movement of a body. Calculate the total distance traveled by the object. So we are going to find the total distance traveled object. There are two options to calculate. We can divide this one into A1, A2, and area 3 to calculate the distance. But it will take time. And we have another option to calculate the distance traveled by area under the trapezium, and this is the relationship that we are going to use. Distance traveled equals height sum of the parallel side. So half, we are going to see what's the height. So that's the vertical height, and the value of the vertical height is 16. So that is 16 meters per second. Now we are going to see the parallel side. So this is the first parallel side down, that we can say A, that is 25 meters. And we can see the second parallel side, that is B, 20 minus 10, that is only 10 meters. So in that case, half of 16 is 8 meters per second. Bracket 25 plus 10 is 35. Sorry, that's the time in seconds, and that's also time in seconds. So that's going to be 35 seconds. So second is cancelled by second. So 8 times 35, I'm sure that is 280 meters. So this is how can we calculate the distance traveled. Here's a list of the question from Cambridge examination from different variants. You can practice according to your region and country and check the answer from the website. Thank you for watching. Subscribe, like, and share the video to spread the knowledge. See you next time with the new topic.